on weekly basis, which are going to help you to get a distinction. This is the only channel which you can use and get a distinction, because whatever we talk about is related to examination, and they expect them in your exam. Let's start with the objectives, and then we see how we can smash them. How we can smash them so that we can get at least distinctions. They're saying consider the structure formula below. If you look at this structure formula, yes, if you try to expand it, you'll find out that it is CH3, C double bond there, and then CH3. So they're saying structure formula. Identify the name of the functional group in this formula. So if it is a carboxylic acid, it's supposed to have at least that. Yes. If a carboxylic acid or ester, so we don't have that. If it is still a carboxyl group, it's supposed to have the same functional group and the homologous series. So this is almost the same thing. So keton and aldehyde or carbonyl groups, they are the same, but don't forget that in here we have the aldehyde and the ketones. So keton, well, we expect the carbon atom to be in the middle of two alkyl groups. So it means that there must be another carbon atom this side, another carbon atom this side. Therefore, this becomes a keton. It becomes a keton. But because they are saying the functional group, yes, because keton is a homologous series, because they are saying it is a functional group, then automatically the carbonyl groups, the carbonyl group, yes, it has both the keton, and it has the aldehyde. So it means that the answer for this is going to be D. So you'll find out that many students will be putting C, of which C is not a functional group. C is the homologous series in that regard. Then they're saying that which one of the following is an empirical formula of 1,2-dichloro. So I expect 2 chlorides somewhere, and then dichloroethane. And then if this is ethane, so I expect it to have at least and then a chloride that side and a chloride that side. So if they're saying one chloride, the second chloride, on carbon atom number 1, carbon atom number 2. So if we count this, we will find out that you have, yes, 2 plus a chloride, 2, you see, 2 of them, 1, 2, yes. So I have C2, 1, 2, 4. So H4, yes, H4, and then 2 chlorides, which is going to give me that. If we have that answer, it becomes the correct answer, which is D. But because they're saying empirical formula, yes, when they say empirical formula, it means that you are talking about the simplest way how you can express this. The simplest way how you can express this. So now, because we can express this, this becomes now the molecular, the molecular formula. Yes. So now it means that if this is 2, 4, 2, 2 can go into 4. So therefore, if I divide by 2, divided by 2, divided by 2, I'm going to have CH2Cl. So if I have this, in the question, then it becomes the most correct answer. Therefore, B is also another correct answer. But because they want the empirical formula, the simplest way how you can express it, therefore this one becomes wrong, and then I get this to be the correct answer. So it's also a confusing thing if you don't take care of it. Then they're saying that consider the structure formula of the organic compound below. This is an organic compound below. So once you are given this, first identify its homologous series. You find out that it is an alkene. It has two bonds between the two carbon atoms. So now, since I know that it is an alkene, it's going to end with that. Now I have to find out the longest chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So any of them is 5, and 5 is pent. But this pent, I need to know the position of the double bond. It's 1, 2. 1, 2, 3. So I'm going to take the 2 because 2 is a little bit shorter. 2. So now, if I say this is the, if now I say that this is the longest chain, yes, so it means that now this, and this, they become the side group. Because I use this direction when I'm counting 1, 2, therefore I'm gonna have the first one is gonna be 1, 2. The first branch is on 2, 3, 4. The second branch is on 4, and then another branch is on 4. But because all of them are the same type, then automatically is gonna have a tri. Tri has one carbon atom, which means meth, which is because they're side groups. Remember, whenever you talk about the side group, the two letters Y, L. So it becomes 2, 4, 4 trimethyl. And then the longest chain is pent, and the position of the double bond is on carbon atom number 2. So it's going to become pent 2 in. Don't forget that a figure and a figure, we separate them by a comma, and a figure and a letter, we separate them by a dash. That's why here it also figure, a letter and a figure, dash, a figure and a letter, dash. So it means that that is going to be the answer. So now we come here and then we find out where is the answer. 2, 4, yes, trimethyl pent 2 in. So this one becomes the answer. So now when you go to another question, they are saying on question 4, they are saying that the following option, choose one that best explains. You see, it can explain, but they want the one which is best explains. Catalysts that are extremely extensively used in chemical reactions. Catalysts can be used to derive equilibrium in desirable direction. Catalyst can decrease the reverse reaction. Catalyst can decrease the reverse reaction. Really? Then they're saying that catalysts have no effect on the reverse reaction. Catalysts cause forward and reverse reaction to proceed at a faster rate. So they're asking you a question that from the option, choose one that best explains why catalysts are extensively, like it is widely used in the chemical reaction. So if you look at this answer, you'll find out that catalyst used to derive equilibrium catalyst can be used to derive equilibrium in the desirable direction. Not only catalyst decrease the reverse reaction. Not only catalyst has no effect on the reverse reaction. That's wrong. Catalyst cause the forward reaction, the forward and the reverse reaction to proceed at faster rate. Yeah, so it depends on which catalyst you have applied. There are some catalysts which favor the reverse reaction at a faster rate or the forward reaction at a faster rate, depending on the producer, what he or she wants. There is one answer which is the most correct answer. So if it is the most correct answer, then you take that. So don't rush to circle or to give the point out. Study the graph, and then when you study the graph, and then match, meaning that what is this x? What is that x going to be? Choose the options. Yeah, we know that these are reactants, and then these are products, and then this is the activation energy for the forward reaction, and then this is the activation energy for the reverse reaction, and then this is the energy, the change in energy or the enthalpy change. And then now, what about this? Because it is an activation energy, which is on top here. If I draw a line touching the y-axis, then what is this? This is a species. It is a complex. That's why you call it a complex, a species, which is in transition. So it's not yet products, and it's not yet reactants. Therefore, we call it an activated, not activation, because the activation is a condition. So we call it an activated complex, the complex which is activated, ready to convert into a product. So if you look at this, B will going to be the most correct answer. Then question 6, they're saying the equation below represents the chemical reaction at equilibrium in the closed container. Yes. If it is in the closed container, they're saying which one of the following changes will increase the yield of hydrogen iodide? Hydrogen iodide. But hydrogen iodide in the above reaction. So first ask yourself, because they're talking about the pressure, temperature. Whenever they talk about temperature, look at the enthalpy. Whenever they talk about pressure, look at the number of moles. So number of moles, so you have 1 here plus also 1 here is giving you 2. So 2 equals to 2. So it means that pressure will not affect, because you have 2 moles before and you have 2 moles after. So when the equilibrium is established, it means that when you increase the pressure, the reaction is going to remain the same, because it will favor the reaction, which is going to, for example, if you increase the temperature, which is going to be in fewer, which is going to have the fewer number of moles. But because the left and the right side, both of them, they have the same number of moles, therefore automatically it means that pressure will not affect that reaction. So where there is pressure, we mean that those two are out. So our answer must be either A or B. So now when you go to temperature, what are you looking for? You look for enthalpy. So you look at this. This is the enthalpy change is less than 0. So it means that enthalpy change is negative if it is less than 0. So it means that the enthalpy change is negative. And if the enthalpy change is negative, then automatically it means that is it endothermic or exothermic? So if it is exothermic, it means that the heat after the heat of the product is lower than the heat of the reactant. So that's why when you subtract, you get a negative answer. And then if it is endothermic, it has taken in heat. The heat of the product is more than the heat of the reactant, and then the heat is going to be higher. Yes, so that's why when you subtract final minus initial, you're going to have a positive answer. So in this case, because it is negative, therefore the reaction is the reaction is exothermic. So if the reaction is exothermic, then automatically it means that if you increase the temperature, the reaction is gonna decrease. If you increase the temperature, the reaction is gonna, if you decrease the temperature, the reaction is gonna increase, because it works better when the temperatures are low. So if you come here, say that which one of the following will increase the yield of hydrogen iodide. So if you look at here, increase in the temperature, no, because this is not an endothermic reaction. So the only answer which is remaining is B, decrease in temperature. So the answer for that case is going to be D. Sorry, it's going to be B. 1.7, they're saying that which one of the following solution of concentration 0,1 has the highest pH. Now, when you look at the highest pH, look at the more high it is, the more alkaline it's gonna be, and the more lower it is, the more acidic it's gonna be. So it means that all compounds which are more of acidic, strong acids, are wiped out if the weak acids are there. So if you look at nitric acid, ammonium chloride, sodium carbonate, and then ethanoic acid, these are acids, but they are weak acids. This is a salt. This is a what? Is a salt. Both of them are salts, but this is going to be a weak salt. A weak salt. Why? Because it is coming from a weak base, which is ammonia. Yes, it is coming from a weak base, which is ammonia. And then this one is going to have, it means that it's going to have the highest alkalinity. Therefore, it means that our answer is going to be C, because the alkalinity is much more than the alkalinity of ammonium chloride, because it is coming from a weak cat ion. It's coming from a weak cat ion, while this one is coming from a strong cat ion, which is a group 1 element, which is sodium. Therefore, the answer is going to be C. Then they're saying that 1.8, they're saying that a solution of ethanoic acid, sometimes you call it acetic acid, which is sometimes you call it vinegar, is titrated against sodium chloride. Now this is a weak acid, and then this is titrated with the sodium hydroxide. This is a strong base. Yes, it's a weak acid and then a strong base. So what does it mean? So if weak acid, strong base, it is a weak acid, strong base, the resultant solution is going to be more of basic than acidic. Therefore, they're asking you that which one of the following indicator would be the best suitable for this titration. So because it's going to be more of basic than acidic, because of the strong base reacting with a weak acid, therefore the indicator which is going to be better is gonna be phenolphthalein. So the answer is gonna be A. Then 1.9, they are saying that which of the catalysts given which of the following correctly gives the direction as well as the medium in which electrons move in the galvanic cell. First of all, what you need to know is electrons don't move through the salt bridge. Electrons move through the external wire. So it means that whatever we have, or whenever we have the salt bridge, so it becomes wrong. So this one goes out, and then also this goes out. So use this technique of elimination so that it makes you to have at least fewer options to pick from. The chances of you getting it right is increased if you wipe out those which are wrong. Okay. Then you have what you call the anode to the cathode and the cathode to the anode. So in this case, you need to know that remember in the saying emission of electron direct gives direction medium. They are saying which cell is this? They're saying the galvanic cell, of which the galvanic cell anode is the negative, and then the cathode is the positive. Anode is the negative, and then cathode is the positive. So it means that electrons will move from the anode, and then they go to the cathode, which is positive, so that there is that attraction. And then when they reach the cathode, that's why we say that cathode is where reduction is, né? And then anode is where oxidation is. So if this is negative, it means that it releases the electrons, and then the electrons move to this side. And then when they reach there, find a species, for example, copper 2, and then this copper 2 is going to gain the 2 electrons, yes, and then it is going to be reduced to copper. That's why he said that reduction is taking place there. So they come from the anode, and then they move to the cathode, see, and then now reduction will take place from there. That's why we shall say that from anode to cathode, but via external wire. Hence, B becomes the most correct answer in this regard. Then lastly is which one of the following have reaction at the cathode during electrolysis of sodium, electrolysis of solution of concentrated sodium chloride. So during the electrolysis of concentrated sodium chloride, you have different ions there, but the ions which are there are some which are preferred than the others. Yes. Yes, you have the positive, which is sodium, and then you have the negative, which is chloride, then you have the OH, then you have the hydrogen. So basically, what is being produced at so this one is going to be preferred than this. So it means that this is going to be the most correct answer. which is D. Then this marks us the beginning of the second question, which is organic chemistry. So before you start, you need to know which groups, which homologous series, which functional group are these compounds. So if you look at this, we shall find out that this is an alcohol. Because of that, this is an ester. Because of that, this is a carboxylic acid. Because of that, and then this is, because this one is here, yes, this is an alcohol because of that. And then this is alkene because of that. And then this is also another alcohol because of that. And then this is a haloalkane. Yes, because of that, or mainly because of that. So, question from the table above, consider compound B. Write down number 1, the homologous series to which compound B belong. The homologous series B, where's B? We have seen it that this is an ester. So B is going to be an ester. Yes, it is an ester. And then IUPAC name of B. They're saying IUPAC name of B. Let's see IUPAC name of B. Where is it? Okay, now we need to find out which one is, first of all, we know that this is an ester. And ester, how do they end? They end with the word "owed." Yes, but you need to know which one came from the alcohol, which one came from the carboxylic acid. So the one which has the carbon double bond is the one which came from the carboxylic acid. So we can take this as the main chain. So it's going to be 1, 2, 3, because there are 3. So it's going to become prop. But because prop is 3, we have to go up to propan. So it becomes propanoate. Now, what about this? This would have called that a side group. Therefore, it's going to become, let's say that that is going to become, we say that it is 1, which means meth, because it's regarded as a side group. So you're going to say methyl. Then we say that this is propanoate. Therefore, it becomes methylpropanoate. And then they are saying that alcohol and acid are heated in the presence of concentrated sulfuric acid. It means that they are looking at the alcohol and the acid, organic acid, in presence of a mineral acid, which is concentrated sulfuric acid, to form compound B. So now we said, what is compound B? Yes, we have seen compound B is methylpropanoate. The role of concentrated sulfuric acid. Write down the role of concentrated sulfuric acid in this equation. So this is the sulfuric acid. We use it as a catalyst. Please don't say it is a dehydrating agent. Please don't say that, because we won't give you a mark. It is acting as a catalyst, or it speeds up the reaction. Those are the only 2 things we can give you marks. Name the alcohol and the organic acid used to prepare. Names of the alcohol and organic acid used to prepare compound B. So if you look at this, we say that this one comes from the alcohol. So it means that the alcohol is going to be meth. Alcohol is going to be meth, which is 1. Meth. So because alcohol we go up to there, meth, and then we put OL, which is methanol. Why? Why are we not putting on the position? Because it's only 1 carbon atom. Alcohol of 1 carbon atom and 2 carbon atoms, we don't put position. Only we start putting positions when it is the 3 carbon atoms. Then we say that this one is the propanoate. Therefore, it means that the carboxylic acid, it must start with that name, which is the So the other one is methanol, and then propanoic acid, and then sulfuric acid as a catalyst. Then they're saying, name the type of reaction which is taking place. Which kind of reaction which is taking place there? The reaction is esterification. Esterification. Sometimes we can call it condensation. Is condensation. Yes, why condensation? Because it results in the loss of water molecules or small molecules, which is an example of water. So at the end of the reaction, you see that when this one is formed, you also produce a small molecule called water. Then they are saying that from the table above, consider compound C. Consider compound C. Write down the name of the functional group of C. So let's go back and find out which one is C. C is a carboxylic acid as the homologous series, as this is a ester as the homologous series. So these are functional isomers. Therefore, these are what we call carboxyl groups. Yes. So it's a carboxyl group. And then they're saying to which homologous series does compound C belong? We have seen it that is a carboxylic acid. Homologous series, it is a carboxylic acid. It is a carboxylic acid. Functional group is a carboxyl group, but the homologous series is a what? Is a carboxylic acid. Then they are saying that differentiate between the functional isomer and a homologous series. When you talk about a functional isomer, functional group, not functional isomer, and then a homologous series. Functional group is, it must be group of atoms. Yes. This group of atoms, it can be one atom, it can be group of atoms. For example, if you talk about OH, or you talk about for ester, carboxylic acid. You see, these are group of atoms. What about that? Bromine, chloride, just one atom. That's why he said that a functional group is a bond or atom or a group of atom. When we talk about bonds, we can talk about double bond, triple bond. Yes, it can be a bond or an atom, a group of atom that determines the physical and the chemical properties of an organic compound. Yes. And then a homologous series, it can be described as the compounds with the same general formula. Compounds with the same general formula, but these, the members, or in which one member will differ from the next by CH2. Yeah, they have the same general formula, but the members will only differ by CH2. Yes. And then they are saying that Write down the homologous series to which they're saying that A, B, A, D, F. Write down the homologous series to which they belong. Homologous series for A, D, F. A, D. A is alcohol. D is alcohol. F. So it means that the homologous series, it is alcohol. And what is the functional group? So the homologous series it is alcohol. So the answer here is going to be alcohol. And then write down the homologous series. Yes. So we have seen that they belong to alcohol. Compound A and D are isomers. As what type of isomer, yes, will they be classified? Compound A and D. Saying compound A and D. The isomer. 1, 2, 3. 1, 2, 3. You see that the alcohol is here. So it means that, let me show you here. One compound, it's like this. CH. Okay. Let me just make them structure formula. See? So it's like that. Don't forget that there is a hydrogen there. Hydrogen, 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 hydrogen. Yes. While the other one is because these are the same alcohol, same number of carbon atom, same functional group, but what is changing is the position of this functional group. Therefore, it becomes position isomer. So this answer is going to be positional isomer. Write down the structural formula of compound D. Compound D. Yeah, compound D, that's exactly what I've drawn here. But even this oxygen must show a bond. Then they are saying that that's the drawing. Then the IPAC name of G. Where is G? G, so it's 1, 2, 3, 4, 5, 6. So it means that it's gonna be 6 is hexane. Hexane, yes, hexane, but I have that, and that. So because this is the functional group, yes, so I'm gonna count from this side.